Okay, guys. I'm audible over here. Yeah. Over the web. Yeah. Okay then. So yesterday we had a first look at architecture. We had not looked at the internal components of Kubernetes. We have not discussed some other areas of Kubernetes. So we'll basically discuss that. We'll try to understand the architecture of Kubernetes, and by the end of this class, at least we should be able to bring up one Kubernetes cluster. This is the whole agenda. Okay, right. Okay then. Okay. So why do I need Kubernetes? Why not a single Docker machine? Okay. So we all know how to run containers in a Docker. If you give me a Linux system, I think most of us will be able to run containers in there. But still, why do I need a Kubernetes stuff? The first reason for that is Kubernetes gives us self-healing containers. What do I mean by that? I think we have seen this as an example in Docker Swarm also. So if something goes wrong, Kubernetes will not fail. It will try to recreate whatever has failed. Okay. So our containers are basically self-healed. Why? Because Kubernetes comes up with that way, with a very specific way of saying that whatever you have asked for is a desired state. Whatever Kubernetes is having right now is an actual state, and it will always try to make actual state equal to desired state. Right? So if your desired state was to run 2 Docker containers and one container is dead for some reason, I'm not trying to tell that it will make 2. It will try to make 2. So from your side, there is no need to have an administrative effort saying that, okay, one of the machine has gone down or one of the container has gone down. Now let me log in into the machine and bring up one more. No, that will automatically happen. So they are self-healing in nature. Am I clear on that? Yes or no? Yes. Okay. Right. And then Kubernetes is designed for so it doesn't speak about, I'm not saying you cannot run small applications over there. Even if your application is large scale, you can run Kubernetes over there. I've given you some examples saying that Google search runs on something like Kubernetes. And if you basically understand, Google search is the most widely used utility across the whole web. So if they are able to scale Google search using a scaling technology, you can use a similar thing basically from Kubernetes also. It is designed for large workloads. Okay. And now the third thing is, okay, so as a person who is writing Kubernetes, basically, okay, we write specifications for the infrastructure in a simple YAML format. They are writing the whole specification in the YAML format, which is not a programming language, right? So it is very easy for us to basically maintain. Okay, Right. And the fourth thing is Kubernetes is okay. Okay, I'll put it in this way. Runs on-premise, cloud, okay, and even on bare metals. Okay, so if you are basically running Kubernetes, it doesn't matter where the Kubernetes is running. Okay, so 90% of whatever you're writing in Kubernetes is same across all of this environment. There will be certain changes. The certain changes is how are you exposing your containers to the outside world. Okay, for that we need some kind of a load balancer. If it is AWS, I'll be using AWS load balancer specification. If it is Azure, I might be using Azure's load balancer specification. Right? If it is bare metal, I might be using some other load balancer. These are the only differences. But the basic point of running the what do you call the workloads on any platform where your Kubernetes is installed, it doesn't change. Okay, and okay, so we have basically spoken about all of this Kubernetes runs and all of that stuff. The basic one of the important stuff is rolling, okay, updates and rollbacks are supported. So I can give a new version. If that new version is not working correctly, I can go back to the older version, and all of this happens while your containers are running, which means your customer will not see any difference whether the application is turned down or not. You might not, it is not necessary for you to take a downtime. That's the whole point. Okay, so you can do all of this. Okay, so on a high level, I'll be using Kubernetes because first thing is they are self-healing. If I run the container, if something goes wrong, it will try to launch it. If my container itself is wrong, then I have to fix it. నేను నా ఇష్టం వచ్చింది రాసి దాంట్లో పెడతాను, అది పని చేస్తుంది అంటే పని చేయదు. But if you have written it correctly, sometimes you get errors, right? And during that errors, you need not worry because one more container comes up and your application is still alive. Okay, then it is designed for large workloads, which means that scaling, high availability, fault tolerance, all of these are basically inbuilt in here. Okay, and then for using Kubernetes, you need not write any magical stuff. You just write a very simple YAML file. Very simple YAML file. Okay. As an administrator, as a developer, I have a different workaround, but our focus is basically on CI/CD pipelines. And in CI/CD pipelines, what we write is specifications. Right? Okay. And Kubernetes basically runs almost on every possible environment. You can run it on VMware in your office. You can run it on cloud. Right? You can run it on individual machines. Okay. There are some versions of Kubernetes which can run on your laptops also. We have something called as Minikube. If you install that Minikube, you can run it on your laptop also. But I'll not be showing Minikube because it is a dev environment and we are not developers. We'll be working on multi-machine kind of an approach. Okay. And Kubernetes by default supports what you call it is not by default. Kubernetes supports rolling updates. So if you can basically use that when your versions are not doing good, you have given a new release. Okay. The developer has done a commit. In CI/CD, what is that we do? We build a code. Once we build the code, we'll build a Docker image. Once we build a Docker image, we'll push the Docker image to some registry. And from there on, what we will try to do is, we will try to deploy the Kubernetes. And let us assume that there are some bugs in that. Okay, there is no need for you to redo all of this. You can do something called as undo the deployment. So then it will go back to what was working earlier. That's the whole point. So reverting back to the last working model is easier in Kubernetes. Clear on this? So if you get all of these features, that's the reason why people use Kubernetes. And Kubernetes is never, understand one thing, if you are running your stuff on one machine with one container, you don't require a Kubernetes. Okay? Then one container run GL. I want to run only one container. Okay? On one server. Okay? So if you are speaking about very, very small scenarios, don't even think of Kubernetes. Go with Docker. Right? Kubernetes is all about when you require self-healing, when you require your stuff to be running all the time, when you require your application deployment to be portable. right? So my customers might be using Google Cloud or Amazon Cloud or Azure Cloud, but I want to give them a Kubernetes deployment. In all the three cases, you can do that. But if you are speaking about in my laptop, I want to run one container, go with Docker container run command, not Kubernetes. Clear on this? It is not about a single application. And Kubernetes is the best way to go for microservices. If your company is working on microservices, this is the best possible deployment which you can ever do. Clear on this? Right? Okay. So this is the major reason why we use Kubernetes, not the individual containers, right? So if you run Docker container run commands, and if that container fails, you have to relaunch it. So which means that if the container fails, you need to get the notification. Yeah. So you have to do all of that stuff. Here, you don't need it. Along with that, we have some advantages, but it would be too much early for me to speak about them. Okay. So we have everything necessary in Kubernetes to run a large scale application as well. Okay. Let it be an application which requires some disk to be present on all the machines. Okay. Or let it be some kind of an application where there needs to be different kinds of communications that happen across each and individual container, right? So there might be a kind of application like Amazon where you need to scale only parts of your application because it is a microservice, right? And whenever your application is interacting with other application, it requires a lot of data. So for example, where is the other container available? What is its IP address, right? What is the username and password to get into the database or fetch the records, write the records? All of that. Kubernetes has a place for everything. Kubernetes has a place for everything. Clear on this? Right? So yesterday we have looked at a very high level architecture, and in that we have said that in Kubernetes you will be speaking with master. Okay? And I have said that master has 4 components, and you will have nodes, and nodes have largely 3 components. So let us look out for what those components are. Okay? So Kubernetes. Yesterday also I've written the same architecture, but that was the first view. We have not got into the individual components of Kubernetes, right? Now I'll be getting into the individual components of Kubernetes, right? So for that, what I'll do is I'll try to open the existing image. I don't want to draw it, man. Log. Scroll down. Okay. So you have all of the stuffs basically. Okay. So, right. Oh, by the way, this is your Kubernetes architecture, right? Okay. So, first let me give the simple image, then we'll get into this. Okay. Why should I give copy image? Okay. Refer here for introduction to okay. Right. And if I'm speaking about Kubernetes architecture, let us copy image address. Open. Okay. Okay. Let me see if this is working. Yeah. Okay, good. So if you look at this image, okay, I've taken this image from Microsoft's documentation. That was a better thing which I could do. Okay. So in Kubernetes, we have different terms to be understood. Okay. So the first term which we need to understand is a cluster. And the second thing which we need to understand is a node. Okay. So cluster is different machines combined together to make Kubernetes work. Okay. And each machine is something which I'll call as a node. Okay. So what is a cluster? Cluster is a combination of nodes. Combination of nodes. So how many nodes do I need to have? It depends on how big your application is. Okay, it is definitely not one. Okay, you have to ensure that your cluster is definitely not one machine. You can make it work on one machine also. That's a different story. But in reality, your cluster will be always plural in nature, not a single machine. Okay, so you have nodes. When you look at nodes, we have two kinds of nodes. One is master, the other one is node. One is the master, the other one is node. The responsibility of master is to maintain this cluster. The responsibility of this master is to do management of everything that is running. Okay. So that is what I basically call it as managing the cluster. Okay. So over here, we have three important terms to understand. One is cluster. First is node. Node is an individual machine which you want to, where you want to run Kubernetes. Right. And then when you combine all of that nodes together, we call it as cluster. Okay. So, and in the cluster, we'll have two categories of nodes. One is master, the other one is node. Okay. The responsibility of the master is management or maintenance of your node. And nodes are the machines where actually the work happens. That is where everything runs. Okay. So your applications run on nodes. Okay. For example, let us assume your company is building Swiggy. So your Swiggy will not run on master. Your Swiggy will run on nodes. Okay. But to make your Swiggy run on nodes, we need someone who is doing the job. That is master. That is master. Am I clear on this? Right. So I'm just writing the terms over there. In Kubernetes, we have a cluster. So what is a Kubernetes cluster? Collection of nodes. Okay. The bare basic motive is they are combined together because they want to run some applications on a Kubernetes. That's it. Right. So and Kubernetes is generally not a single machine, it is a multi-machine. And that combination is something which we call as cluster. And then we have something called as master node. I'm not writing individual things because we have discussed almost a similar thing in Docker Swarm also. Alright. So what is the responsibility of the master node? Management of Kubernetes cluster. And then we have node. Okay, let me write it as master and node. They look in a better way. Okay. So node is actually where the work happens. So node is where applications run. Okay. So we need manager or master to make nodes to nodes for the nodes to be effective. For the nodes to be effective. So for example, if I want to simplify what is the responsibility of the master, I am quite sure that you might have seen a football match. Okay. Even if you have not seen the football match, I am quite sure recently Vijay came up with a movie called as Bigil or Vigil in Telugu. Yeah. So in that you understand that Vijay's role, right? He is a football coach. And even in Check Day, we have Shahrukh doing that for the people who don't follow South Indian films. Right. So what was his role actually? While those people were playing on the field, what was Shahrukh or Vijay doing outside the field? Yes, they were managing the game, right? In cricket, doesn't happen. That's where I can't take the cricket example. But if you look at football or a hockey match, there will be one person screaming in a very well-dressed suit, but not behaving as per that suit, right? So he will be screaming and he'll be changing the players. He'll be doing all of the decisions and all that stuff. So exactly that is what the responsibility of the master is. So if you don't have master, right, your goalkeeper might be standing at some other's goal post, right? So he arranges the basic whole team to organize in an organized fashion, saying that you have to run there, you have to run there. Okay. So since that is not working correctly, let me do a switch now. This container is not doing good. So let me replace the container. Let me rerun the stuff. So we need someone who does that, and that someone is master. Okay. So for the master to do his job, he takes the help of some internal components. And each component which is present in the master has a well-defined role. Am I clear on this? So master, node, cluster. Three simple terms. Okay, we'll be adding more terms to it. In Kubernetes, we have a lot of terms, right? Okay. Now let us look at individual components. So, are you looking at Kubernetes symbol? Yes. So this is nothing but a wheel that controls the ship. So if you have basically looked at ships, or we'll have one wheel which basically controls that stuff. That's where, because Docker has taken that container or a shipyard kind of a terminology. They have taken this container, or they have taken a whole large ship which can carry the containers and all that stuff. That's where they have this terminology of that wheel. Okay, this icon which is I'm trying to speak about. Okay, so in the master we have 4 components. Okay, so the first one is Kube API server. The second one is scheduler. The third one is control manager, and the fourth one is etcd. We have 4 components. What are they? Kube API server, scheduler, controller manager, and etcd. Right? Okay. So each of them have a well-defined role. Okay. Let me try to speak about the responsibility of Kube API server. Okay. So yesterday I've said that as a user, you will be speaking with master. So actually you will be speaking with Kube API server. When I say you speak with master, you will be speaking with Kube API server, because a user can communicate to an API server, which is a component which basically takes care of this responsibility, is Kube API server. And whenever you are speaking with Kubernetes, you are speaking with that component. And what that component basically does is, it basically does couple of interesting things, right? Even these internal components, whenever they want to communicate, they will take the help of Kube API server. So Kube API server is responsible for all the communications. Am I clear on that? Yeah. And then are you seeing etcd? Okay. So whenever something which you ask, okay, you are trying to tell that this is what I want to do. So your desired state. Okay. How many nodes do I have in the cluster? Okay. So what is actually running now? Okay. All of these are details about your Kubernetes cluster. Yes or no? So you can think of etcd as the memory of this Kubernetes cluster. Whatever is happening in Kubernetes cluster will be stored in etcd. Am I clear on this? etcd is a memory of Kubernetes cluster. If you remove that, okay, it will be Gajini then. It will forget everything. Okay, that's the whole point. If you mess up with etcd, it will forget all the details. All the details about your Kubernetes cluster are stored in etcd. Clear on this? Right? So, are you clear about these 2 responsibilities now? Anything and everything about your Kubernetes cluster is stored in etcd. Right? So, if you look at this image, etcd. Okay. Cluster store and kuda antaru then. I'm directly writing the product's name there. etcd is a product actually. Okay. It is a distributed key value store. Okay. Fine. Now we have scheduler and we have controller manager. So what is the responsibility of scheduler? Whenever you have to, basically, if you look at this, whenever you have to create anything which is new. Anything which is new. So for example, you have said that I want to run 30 containers. So you want to create 30 containers. That's where your scheduler will come into play. So whenever you have to create anything new, this scheduler will schedule whatever you have to create on the nodes. Whatever you have to create on the nodes. Clear on this? Yeah? అర్థమవుతుందా? ఏదో వేరే భాష మాట్లాడుతున్నట్టుందా? అంత ఆవేశంగా ఎందుకు చూస్తున్నారని నాకేసి? టీవీ డిబేట్లనేమో ఆనందంగాను, నాకేసేమో బాధగానో చూస్తారే. రైట్? ఓకే, ఫైన్. And then next, controller manager. This controller manager, right? Whenever something is in deviation. So for example, your node has gone down. Okay, one container has gone down. Whenever your system is basically trying to basically something unusual happens on your system, this controller manager will be aware of it. Okay, to be very specific. Okay. In controller manager, we have many other components internally. Okay. So if you look at over there, are you seeing something called as node controller? This node controller component will come to know whenever one node goes down. Okay. And then there is something called as replication controller. Replication controller is you have said that I want 3 containers to be running, but the desired actual state has turned to 2 because something has gone wrong. So that replication controller will come to. Similarly, we have an endpoint controller, which means that whatever is running inside your cluster, you want to expose it to the outside world. Okay. If something is going wrong there, this controller will come to. So basically, the responsibility of this controller manager is to ensure whatever the desired state which you have asked for is maintained or not. Is maintained or not. Am I clear on this? So, on a overall note, on a very high level, master maintains your desired state equals to actual state. But if you get one level deeper, he is responsible to notify. If it is not met, he will basically make the necessary decisions. Okay. And now if you look at scheduler, okay, whenever you want to assign any new work on the nodes, right, scheduler will do that for you. Scheduler will do that for you. Am I clear on these 4 components? Okay. API server responsible for communication. HCD responsible for storing everything, right? Scheduler for scheduling any new jobs or new activities on your nodes. And then we have controller. Controller manager is responsible to inform if the actual state is not equal to desired state. So for that, they have different kinds of controllers. Node controller, which will basically inform if the actual nodes were 7, now it has become 6. If something goes down there, it will try to inform. Okay, right. So are we clear on these 4 components? Okay, and this master can be installed on any Linux machine. Your Kubernetes master cannot be a Windows machine. Am I clear on this? Yeah, tomorrow if you can say that, can I run Kubernetes on Windows? The answer is master you cannot run. But let us see whether we can run node or not. Okay, am I clear on this? So a Kubernetes master is always a Linux machine. And now, who is the memory of Kubernetes cluster now? Kubernetes master now? HCD. Tomorrow, let us assume that if I have only one Kubernetes server, it might fail, right? It might go wrong. So what will I do? I'll have one more. So between these 2 containers, what is actually shared? What is actually shared? Smart Shankar lo chip lo emuntadi? Memory, right? Yes. Now what is the memory in this cluster? HCD. So between 2 Kubernetes clusters, HCD will be in sync. HCD will be in sync. Okay. Because if you want the memories of one person to be transferred to the other person, we have many Hollywood movies, but recently even Telugu movies have tried that. Okay. So even Disco Raja is the same thing, right? If I'm not wrong. Some kind of the same stuff. Or no, not. But whatever it is. We are basically, if you want another cluster or another server to do the same job, it should know what has happened in HCD there. So if you want to make your Kubernetes high available, what is that you are trying to do? You are trying to make 2 HCDs have the same data. 2 HCDs have the same data. Okay. So there was a big discussion. I'm not sure why it is done, but there was a discussion long back in Kubernetes saying that in Kubernetes I'm running all of these 4 components in one server itself. Why should I run all of them in one server? Why not on multiple machines? That was a discussion. But there are a lot of Kubernetes versions changed. This architecture has not changed, but there might be changes. Okay. If Kubernetes architecturally has some issue, that is this. Okay. So if my HCD is altogether on a different machine, then it will be better than having all of them in the same machine, but they might have some other issues. But this discussion has done to my knowledge, this is discussed from the last 3 years, but there was no change in architecture, right? So we might or we might not see that, but that's the discussion which we had. So if I am having 2 Kubernetes masters, what do they mean? We have 2 Kubernetes masters, with each master will have all the 4 components, but the HCD will be same in both the masters. Okay. So when you write the data to one HCD, it will be copied to the other HCD. And HCD, the reason why Kubernetes takes HCD is, if you remember, I have said that HCD is a distributed key value store. HCD is designed to work with multiple machines. HCD is designed to work with multiple machines. So there is need not be any special stuffs like database, right click on it and then say this is my replication server and then do failover. You don't need that operations. By default, HCD is designed to work with multiple servers. So that's what Kubernetes has taken an advantage of. Am I clear on this? Okay. So fine. This is what Kubernetes is doing for management. But let us see the machines of interest, machines where our applications run. What is happening over there? So if you see over here, the first thing is your Kubernetes node can be a Linux or a Windows machine. Okay. So can I run Kubernetes on Windows? The answer is not master, but you can run node. Am I clear on that? That's the first thing. Right. And in Kubernetes nodes, we have three simple components. One is kubelet. The other one is, second one is container runtime. The third one is kubeproxy. Okay. Let me start with container runtime. Container runtime is nothing but the container technology which you are installing over there. So in our case, that container runtime is Docker. In our case, my container runtime is Docker, right? If I am using Rocket as a Docker technology, then my container runtime will be Rocket. So container runtime is nothing but what is the container technology which you are using. In all of our case, it will be a Docker. Okay. So node needs to have Docker installed. Even master needs to have, but in here we have a container runtime. Okay. Right. And then we have kubelet. Okay. So in master, we have lot of things doing the job. Okay. So on the node, master will tell the node saying that do this, yes or no, do this activity. So create this container or do whatever it is. So master will tell commands or will give instructions to the node. And this kubelet is an agent which receives those instructions and starts doing that activities. So kubelet is the reason why we have a kubelet is responsible for taking all the necessary instructions from your Kubernetes master and performing them. So kubelet is an agent which receives all the information from your master. But remember one thing, kubelet is not intelligent. Kubelet does only what your master says. Right? Kattappa in Bahubali. Right? So even if she is asked to murder someone, it is okay to do that. Okay. So kubelet is not, it will not make any decisions. It will just follow instructions. Clear on this? So if the container is dead in there, it will not say that okay, container is dead, let me launch. No, it will inform the master. So to be very specific, kubelet will inform the your controller saying that okay, one container is not running over here. Then it will again receive the instruction saying that okay, now the container is not running, launch one more. It will never make decisions. It will do only one thing. It will follow the instructions and it will inform your Kubernetes master. Okay. And then kubeproxy. So remember in Docker, we have spoken about multi-host networking. So whenever you have two nodes, we will have an overlay, right? And overlay uses a bridge internally. Okay, it uses underlay and all of that stuff. There was a networking discussion over here. In Kubernetes, all of that networking with respect to your cluster is maintained by kubeproxy. So kubeproxy is a networking component on each node. When you run Kubernetes, you will get some IP addresses. And kubeproxy is responsible for giving those IP addresses. Am I clear on this? So on the master, we have 4 components. On the node, we have 3 components. So Kubernetes node has 3 components. One is kubelet, the other one is container runtime, the third one is kubeproxy. So kubelet is responsible for taking instructions from master, and the container runtime is your container technology. In our case, it is Docker which you have installed. And then kubeproxy. Kubeproxy is responsible for all the networking, right? So kubeproxy has networking related activities. So let it be service discovery, let it be giving IP addresses, right? Let it be like giving DNS names, DNS resolutions, anything with related to network on the node is kubeproxy's work. Am I clear on this? So what are the 4 components of master? API server, scheduler, controller manager, and then HCD. What is the responsibility of APS server? It is responsible for communication. So when you want to communicate with someone, when master wants to communicate with someone, right? APS server is responsible for that communication. So to be very specific, in Kubernetes, the component with which you speak is APS server. Okay, and then HCD. HCD is a memory. Whatever you do in Kubernetes, everything is stored in HCD. Okay, and then we have scheduler. So scheduler is responsible for assigning any work. Okay, anything which is new. Okay, on the nodes. So which means that scheduler will speak with kubelet to give the instructions to do anything new. Okay, and then we have controller manager. Controller manager is responsible for ensuring that your actual state is equal to desired state. If your actual state is not equal to desired state, it will take the necessary actions. It will take the necessary actions to make your actual state equal to desired state, right? And then this is a master component. If you go to the node, we have three components. One is kubelet, which is responsible for receiving the instructions from your master. And then we have container runtime, which is your Docker, which you have installed. And then we have kube proxy, which is responsible for all the networking on your nodes. When I say networking, it is container networking, not the physical networking of that system. That doesn't work. So this is responsible for giving the networking to whatever that runs in Kubernetes cluster. Okay. So in Kubernetes, I am running an application. So to that application, I have to expose 8080 port, right? So that 8080 port exposing responsibility, since it has to deal with networking, is up to the kube proxy. Okay, and kube proxies of multiple machines will be in touch. It will not be on one node. Multiple kube proxies will be in touch. All right? Okay. So, and master has to be a Linux machine, and node will be a Windows or a Linux machine. Good. Okay. So any doubts so far? Okay. I'm not going through all of this, but okay, what is 100? 100 Kubernetes at HCD we same, I'll not tell that. HCD will have same data. Okay. HCD might not be same, but if you go into all the 100 nodes and look into what is there in HCD, all the 100 will have the same data. Yeah. How the controller manager knows what the desired state is and how the controller manager knows what the desired state is. Okay. So where is that we are storing all the information in Kubernetes? HCD. So can the controller manager dig the memory? Yes. Storage తో మాట్లాడుకోవచ్చు, దాని జ్ఞాపకాలతో మాట్లాడుకోవచ్చు కదా, అదే జరుగుతుంది. So whenever you want to know any information about Kubernetes, when it deals with memory, it is always, or storage, it is always with respect to HCD. Okay. Why does master works only on Linux? Because that's how Google has decided it. అంతే, అంతకు మించి పెద్ద లాజిక్ ఏం లేదండి. Master works on Linux because that's how Google has designed it. That's how Kubernetes has written it. And no one has time to make it port to make it available on Windows. The day when they make it available on Windows, I'll be the first person to inform you. Right? Okay. XCD is shared between master and client. What is XCD? XCD. Okay. ETCD. Oh. Okay. So HCD is not shared. HCD is a memory, right? Depending on that memory, the necessary actions will be taken, right? So for example, he said, I want to run 3 containers. So your desired state in HCD is stored as 3. Now in reality, you have only 2. But what is the master's responsibility? To ensure actual state is equal to desired state. So every information about your Kubernetes is stored in HCD cluster, ETCD. Okay. Okay. If you have a Docker image, what is the role of Kubernetes? What is, if you have Docker image, what is so special about Docker image? What can Docker image do? It can help in creating containers. Okay. But if you can create containers only by running Docker container run commands, if they fail, who is responsible? You are responsible. But over here, if you put the same image and make it somehow run in Kubernetes, then if something goes wrong, it is trying to self-heal. It is trying to make your application work. That's the reason why I'll take it over there. Okay. Right. Does HCD act as a shared volume? No. No. HCD is not a volume. It is not a disk. It is a distributed key value store. It is a software product in itself. Okay. can we have Kubernetes master and nodes on the same server? Why? Why do you want to do that? If you want everything on the same server, don't use Kubernetes. That's the whole point which I was trying to make. Okay, but if you are keen on doing that, that is something which you do in dev environment, and for that you have something called as Minikube. Okay, yeah. So we need to reboot Linux box several times like Windows box. That is why masters can run only on Linux. Oh, is it? Okay. No, sir, that is definitely not the reason. Okay. The reason booting has no stuff. If that was the case, does the nodes do not require a boot? Okay. What will you do if you have only one node and one master? Then if node requires a boot is not a reason for that. The basic reason is this technology all started in Linux. Okay. It is when they port it. Right. Okay. So some components are possible to be ported because of the Windows support. Some components might not be possible for whatever reasons of the Windows kernel which they have. Okay. If Kubernetes has so many advantages, where Docker is used without Kubernetes? Okay. In Kubernetes, do I need Docker or not? Okay. Jagadish, Kubernetes node has one component called as container runtime. What do I mean by container runtime? Docker. So to make Kubernetes work, do I need Docker or not? So where is Docker used in Kubernetes? Everywhere. Okay. Because you are eventually using Docker to launch your containers. Okay. Kubernetes is an orchestration engine. Yeah. Okay. Yeah. 100 Kubernetes cluster. 2 clusters fail. Even though what is cluster? 100 Kubernetes machines will have only one cluster. Where are 2 clusters coming in from? Okay. And then out of in that cluster, if you have 100 machines and if 2 machines fail, it depends on which 2 machines they have failed. If 2 nodes have failed, nothing will happen. If you have 2 masters and 2 masters have failed, then everything will not work. Yeah, that depends on what it is. Let me answer this question and I'll come to it. Okay. Okay. For all HCDs will be in sync? Yes, they should be. They should be. Okay. Yeah. If the node dies, which node creates? Node scheduler or node controller? Anything which is new is scheduled by scheduler. Controller manager, what it does is it will identify that, okay, you have said the actual state is should be 3, but actually it is 2. And it will make that entry inside the HCD. Once that entry is made, then the new decisions will be made. That's how it is. Right. Okay. Okay. Man. Okay, మీరు అడగండి. Okay.
Master side network component.
Master side, there is no networking component. Okay. Master side networking, basically master side will tell what should be your network. Okay. And depending on that, your kube proxy will behave. Okay. So to be very specific on the master, it will decide what should be your network. Okay. And obviously, whenever it is deciding, it will have a network connectivity with it. It depends on what you're asking. So networking decision will be made by your specification, to be very specific. The default, stuff will be decided by master. But if you want any customized network, it is your specifications decision. See, all the components, basically communication, it will be basically even your network is a specification. That specification will be passed across to that. Kube proxy, when it starts, it has the ability to listen to the commands which you receive. So that's what is happening basically. So whenever you install, this is not like, so I am installing a new master and I am installing a new node. So now master will tell kube proxy install now. No. So when your machine itself is installed, you have a kube proxy which runs with some kind of a connectivity. And it has a capability to receive commands from the stuff, right? Yeah. Okay. It is not like a new network. అంటే అడాప్టర్ లాంటిది ఆల్రెడీ ఉందనుకోండి, దాంతో మాట్లాడటం నీకు తెలుసు, అది చెప్పినట్టు ఇది వింటుంది. ఓకే, రైట్. ఇఫ్ ద నోడ్ డైస్, identifies by HCD cluster, informs to HCD, tells to scheduler to create one more node. Yeah, sounds like a decent stuff. Okay, but any information that is passed to any component of Kubernetes will be stored in HCD. Okay, so when you have said that your actual state is not equal to desired state, then what should happen? Your scheduler has a responsibility now. It has to start something new. So scheduler will pick in. So all of these components will be always in touch with HCD. Always in touch with HCD. Right. Okay. What is the communication protocol between master and node? TCP. Nothing more than that. It's a TCP. They work on the normal kind of a communication itself. Right. And they also use a little bit of UDP, but it's mostly TCP. Yeah. Okay. How many maximum nodes can we create in cluster? What is the maximum number which you know? మీకు తెలిసిన పెద్ద సంఖ్య ఎంత అంత అనుకోండి, right? Because there is no limit, right? When Kubernetes was designed, they have not designed saying that you should have these many nodes itself, or you should have these many masters. There is no limit. It depends on how much you can afford. Yeah. Okay. If two clusters fail, what is two clusters, sir? I didn't understand two cluster language. So whole of Kubernetes is one cluster. Okay. Two clusters means two different set of machines now. Yeah. మీకు రెండు క్లస్టర్లు అన్న భాష ఎవరు చెప్పి నేనైతే చెప్పలా. ఓకే, మరి మిగతా ఈ పాటలు ఈ గ్యాప్ లో ఈ జ్ఞానం ఎలా వచ్చింది మీకు? రైట్. సో ఇఫ్ యూ లుక్ ఎట్ క్లస్టర్, ఐ హావ్ డిఫైన్డ్ క్లస్టర్ బై సేయింగ్ ఇట్ ఈస్ కలెక్షన్ ఆఫ్ nodes. So as of now we are speaking only about one collection, which means we are speaking about one cluster. So cluster failed means master gone down. Cluster failure is equivalent to your master down. If your master has 3 servers, all the 3 are down. If your master has 1 server, or 1 server is down. That's the only case when your cluster fails. Okay, right. Okay. When the node dies, what is the flow of creating a new node? No, when a node dies, new node will not be created. When a node dies, whatever was running on that node, it will ensure that it is distributed to all the other nodes. Because Kubernetes has no strength or energy to create nodes. For example, you are running this on physical machines. If one physical machine is removed from the network, Kubernetes will not know about it. It will not know how to create a new node because node is a machine. If you are running this on AWS, right, Kubernetes has no knowledge of how to create virtual machines. But what Kubernetes can do is, what was running on that node, it will distribute across the other nodes. When I say distribute, it is not moving from there to there. It will recreate. It will recreate. Okay. So let us assume this story now. Kubernetes is acting like a monitoring system. Man, please. అంటే మీకు ఇలాంటి భాష అసలు ఎలా అవుతుంది? వాట్ ఈస్ మానిటరింగ్ సిస్టమ్? క్యాన్ మానిటరింగ్ సిస్టమ్ టేక్ నెసెసరీ యాక్షన్స్, ప్రివెంటివ్ యాక్షన్స్ క్యాన్ ఇట్ టేక్? రైట్. సర్వర్ చచ్చిపోయింది అని మెయిల్ వస్తుంది. సర్వర్ ఈస్ డెడ్, యూ విల్ రిసీవ్ ఎ మెయిల్. దట్స్ ఎ మ్యాక్స్ వాట్ ఎ మానిటరింగ్ సిస్టమ్ క్యాన్ డూ. ఈస్ Kubernetes doing the same thing? No, it is self-healing. Then how can, it has monitoring, right? It is a monitoring system. Please don't come to that conclusions. If that was the case, I would have started my class by saying Kubernetes is a monitoring system. We use this to monitor clusters and all that stuff. No, right? Okay, right. Do we need to manage master by running commands? If you are installing Kubernetes in your office on your own, then it is the responsibility of yours to manage a Kubernetes master. But if you have used the services like AKS or EKS, which are spoken about, then you need not worry about master, right? So let us assume this is a master and I have 3 nodes. Okay. So on 3 nodes, let us assume that I'll take some application. Okay. Okay, let me take this one. Yeah. So let us assume that one of your application was running on this node. Okay. So, and due to some reason, this node has failed. So that means this application is also down now. Okay. Now this application cannot be moved to the other stuff. When a node goes down, what this master will do is, in HCD, actual state is not equal to desired state, right? So now what the scheduler does is, scheduler tries to create this new application again. So it says that, okay, now you go and create this application on this node. Okay, it is not moving the application. It is recreating the application. So then you might say that, okay, that application might have generated some data. You should have used volumes. Yes or no? If your application is generating data and if you need to preserve this for future purposes, if you remember in Docker, we have discussed a topic called as volumes. You should have designed your application with volumes. If you are leasing your stuff, that means you have designed it incorrectly. Okay. Then you might ask, this machine had some IP address. Will I get the same IP address to this? Okay. Your application will never get the same IP address. But remember, your application is exposed to the outside world by using some kind of a load balancer. These IP address will not be changed. So your customer is using the same IP address. Earlier, the request used to go to this. Now, since this is not working, it is going to. So to the outside world, nothing is changing. Yes or no? If you are looking at from outside world, you are using the same IP. Okay. But internally, what has happened? Our node has gone down. Your application was running there. Now it has moved to a different stuff and you are accessing it in the same way. That's how it works. Am I clear on this? So it is not moving containers. It is always creating the stuff. Okay. So are you seeing this communications saying that, okay, so you have some kind of a load balancer kind of a tough and from load balancer, your request has to come to this. This will be done by kubeproxy. This is what kubeproxy is all about. Okay. So every application that is running will get an IP address. Okay. So what is the CIDR range? What is that stuff that will be all maintained by your kubeproxy? Clear on this? Now did we understood this concept? Okay. So node going down, node cannot be brought up. All right. Whatever your application is running, wherever your application is running, if your application goes down, okay, which is running in format of some container, that can be brought up. Yeah. Not really servers. Serverly తెచ్చుకునే బాధ్యత your infrastructure layer. And Kubernetes is not the infrastructure layer, right? It runs on infrastructure, right? So, for example, if one node goes down, how do I bring one more node? That is your Amazon headache. That is your Azure headache. So, in Amazon, we have something called as auto scaling group. Ensure that your auto scaling group number is right. In Azure, we have something called as VM scale set. Ensure that you are configuring that if you really want to maintain node count. Okay. But Kubernetes is not about nodes. It is about what happens inside the nodes. Clear on this? Yeah. So on this architectural components, are we clear? Okay. So in reality, on production systems, never ever run your production system with one master. Always ensure that you have multiple. And I've already said odd is a better number. So go with 3 or 5 or 7. You go with a odd number of master nodes. Okay. And when it comes to the nodes, it is your choice. It depends on how many applications do you require. That determines what is your node count. Okay. But master, ensure that it is odd in number. Clear on that? Okay. Right. And now let me give the link of this. Okay. Refer here for, I will not be writing Kubernetes from now. I will be writing K8s, right? For okay. Now, okay. So when you install Kubernetes, you get this web UI also. Okay. So we'll be discussing about these things, right? So how Kubernetes basically runs your applications. Okay. So what we know is containers, right? Till date, what we know is what? Containers. Kubernetes doesn't know containers. What Kubernetes knows is pods. In Kubernetes, what is that you will be creating? Pods. And your application will run inside a pod. To be very specific, your Docker container will be inside that pod. Kubernetes doesn't know about containers. The smallest unit of creation, okay, in the case of VMware is virtual machines. In the case of Docker is containers. In the case of Kubernetes is pods. And inside one pod, you can have container or containers. How many? That is left to your stuff. But the best practice is always to have one container. Okay. But you can go with more than one also. Am I clear on this? So in Kubernetes, if you want to run application, you will be running it inside a pod. Okay. So inside a pod, your Docker container runs. So to run a Docker container, you need a Docker image. Okay. So we are getting into the same stuff, but your Docker container runs inside a pod. And we will not be deploying individual pods actually. If you remember, we want a rolling updates. If that application is not working correctly, we want to go back to the older version. By the end of this journey, you should be able to write deployments directly. In Kubernetes, what do I want to write is, I want to write deployments. What is an advantage of deployment? I will give a new release. If that release is not working correctly, I can go back to the older release. But if I am working with individual pods, I cannot do that. I have to work with deployments. Right? So first, the basic workflow is, remember our application was running in the office. Right? For that application, whatever was running, we have learned how to write a Docker file. We have learned how to write a Docker file. Okay. So that Docker file helped us in creating a Docker image. That Docker image will help us in creating a container. Right? This was the basic story. Now that container, whatever we have, that image, whatever we have, right? That container will not run by Docker container run command, but it will be running inside a pod. Right? To create this pod, you will be writing some kind of a specification. Right? And you will not be writing specification for individual pods, but you will write it for deployment. So whenever in DevOps pipelines, and eventually what you write in your YAML file is, in the YAML file, you will be writing about Kubernetes deployments. We will also learn about something called as Kubernetes services. Okay. And then we'll also be speaking about Kubernetes volumes. There are many stuffs over here. So we have to discuss about Kubernetes objects. Okay. So, but let us not worry about it. But for now, am I clear on this? Yeah. So your application, first try to write a Docker file. Then try to build a Docker image. Once you build a Docker image, right, you have to do some step which I have not spoken about right now. Okay. We'll be finishing that step also during this weekend. Okay. Right. So after that, you will be able to run your application inside a pod. And your pods you will be basically deploying using something called as deployment. Right? Or you can do one more thing, that is something called as replication also. If you remember in Docker Swarm, I have run Docker service create -- replicas 5 or 2 or whatever it is. If you want to do something like that, then you can use something called as replication also. But deployment is much more stable. Okay. So when as a DevOps engineer, you eventually will write deployments. But when we start our journey, we start from ground zero. We start from very basic stuff. Clear on this? Right. So what we will do right now is, we will let us try to create one Kubernetes cluster. Okay. So in Kubernetes, there are many ways to install Kubernetes cluster, and I'll be using one way. Okay. Right. And in Kubernetes also, you have some kind of a playground, like Docker playground. But somehow it is not that stable. Okay. So let us install our own Kubernetes cluster. Okay. And whatever I'm installing right now is not production ready. Whatever I'm installing right now is not production ready. So it is okay for dev environments. It is okay for test environments. And all of our discussion will be, our dev and test environment will be in whatever installation way which I'm trying to speak. And our production environment is in AWS EKS or Azure AKS. This is what we'll be doing. Right? Because in production, I need not worry about my master. I have to worry only about my applications. That's the whole idea. Clear on that? Yeah. Okay then. So we'll go out for a break, come back, and then we'll discuss about how to install that Kubernetes. And we have some areas to speak about Docker file and all of that stuff. If we have finished our installation successfully, then basically what we will try to do is, we will try to speak about the Docker files, even environmental variables, arguments. We have some of the other areas, right? So then we'll get into using Kubernetes cluster, right? Okay then. So I'll stop it at that. Well, basically, can a Docker file be used in Kubernetes? No, it has to be, right? You have to use an image, because in pod your container has to run, and for a container to be run, do we require an image or not? So, right. So from Docker file, you create an image, and that image will be used in your, yeah. Okay. What is pod? Pod is the smallest unit of creation in container in your Kubernetes. Okay, we'll discuss elaborately on pods, but I'm trying to tell you the setup, the overall picture, right? So in Docker, we used to run containers. In Kubernetes, we'll be running pods. What a pod is, we'll discuss about it. Okay. So in VMware, we were running virtual machines. In Docker, we were running containers. In Kubernetes, we'll be running pods. Just have this relation in place. That is more than enough. Okay. Thanks. What time we can be back? It depends on how much time I get a tea. There are a lot of other external factors, right? On an average, it takes somewhere around 15 minutes, right? Yeah. Okay, guys. Huh? So right now, we will try to install a single master cluster. Okay. Single master cluster has its own problems. If your master is down, whole Kubernetes is down. But understand, this is a dev environment or a test environment, so it's okay for us. Okay, right. And then what I'll basically try to show you is Kubernetes installation. I'll go to the official documentation of Kubernetes. Okay. Okay. So if you basically look at Kubernetes, right, there are many ways of installing Kubernetes, right? He's trying to tell that he has given the documentation as learning environment and production environment. Learning environment is it will run, all of this will run on your own laptop or a free service. Okay. So Minikube can be run on your laptop itself. Okay, right. And then they have Kubernetes in Docker. If you go with Docker installation, right, on an EE mode, enterprise, we have installed Docker community. But if you install Docker Enterprise Edition, you can enable Kubernetes in that itself. Okay, but these are good for dev or running on a single machine. The moment you go to the production kind of environment, we have various different kind of solutions. You have managed, you have turnkey solutions, you have on-prem, and then you have custom installations. Right? Kubernetes has many ways to install. Okay, so you have managed stuff. Managed is generally given by your providers, and if you see, these are all different ways of installing Kubernetes. Yeah. So these are all the providers who basically give Kubernetes. So to install Kubernetes, we have many ways of installing Kubernetes, right? So The way which we'll be following is, okay, installation will be done using kubeadm. So what is the approach which we are trying to follow? There are many ways. I'm not trying to tell that this is the only way. This is good for dev test, not really for production. The reason I am trying to tell it is not ready for production is all the components of kubeadm are not in released mode. There are some components which are still in beta mode. The moment when all the components come to a release state, then you are good for basically using that in production. But still some companies use kubeadm for production, even though Kubernetes is not recommending it. That is your company's risk which they are trying to take. Okay. So there are many ways of installing Kubernetes, and we will be using kubeadm because it is easier approach. There is no other reason for that. kubeadm is something which you and me can install easily. Clear on that? Okay. Our ideal production environment will be Kubernetes as a service on the cloud, AKS or EKS. Okay. So where master will be managed by the cloud, and we will be worrying only about the nodes. This will be the scenario which we will be speaking about, right? Okay. All right. So now if you want to install kubeadmin, then you just say kubeadm installation and try to use Kubernetes documentation itself. It is far better than any other documentation which you would go. So if you see, I'm basically using Kubernetes documentation itself. Okay. All of our Kubernetes classes will be from Kubernetes documentation itself. I'm not using any other stuff, right? Earlier, they were not that great in documentation, but they have updated. After Docker has given a good documentation, Kubernetes also had updated their documentation, right? So, yeah. So, are you saying installing Kubernetes, we have kubeadmin. Okay, you have something called as kops. You have something called as crib. You have something called as kubespray. And your company might use any of them. Okay. In this class, I am using kubeadmin. If your company uses kubespray, click over here, see the steps, install it. Yeah. So if you are speaking about all the possible installation solutions, that itself will take 1 month. Okay. So if you look at turnkey cloud solutions, so how does it work on AWS? How does it work on Azure? Okay. If you look at on-premise VMs, we have the following options. If you want to use Windows in Kubernetes, what is that you're supposed to do? And what are the best practice that you need to follow? Okay. So out of all of this, right now we are trying to take kubeadmin. Okay. Kops was earlier a decent approach. Now Kops is not recommended because in AWS we didn't have a Kubernetes solution earlier. So to install Kubernetes on AWS, we used to use this Kops. But right now we have EKS there, Elastic Kubernetes. So right now, right now what we will be doing is we'll be looking at kubeadmin. To install kubeadmin, what you need is some Linux machines. They might be in your office, they might be in cloud, or they might be anywhere. So we'll be using Kubernetes machines, and you can use this installation easily on any Red Hat. Okay, not Red Hat, CentOS. I'm not calling it as RHEL because in RHEL the problem is you have to have a subscription. To install Docker, you have to have a subscription or you have to go with a difficult installation. But if you are using CentOS, Fedora, or any other Red Hat flavor for that matter, or any Ubuntu flavor, you can use it. Red Hat Enterprise Linux has a subscription stuff. If you have a subscription, then you can use the same stuff, right? So in your organization, you'll have subscription there, so there is no need for you to worry about it. But over here, we'll be using Ubuntu flavor. All right. So our installation will be using this, and the architecture which we'll be doing is something which looks like this. Okay. So you'll have a single master, you'll have some nodes, and then we'll be speaking with our API server using something called as kubectl. Okay, yesterday I think I've said you 2 ways. There are 2 ways of interacting with Kubernetes master. One is using YAML, which is kubectl. The other one is they have an API based method where you can use basically JSON, which can be spoken over a Python based REST API or Go language based REST API, or to be very specific, since it is a JSON, you can use other languages also. Okay, since we'll be working with specifications, we'll be using kubectl. So this is going to be our environment. Am I clear on this? Yeah. Okay. Now You have to just basically follow this installation. Okay, right. So for this installation, he's asking us to take four 1604 machines. I'll not start from 4. I'll start from 2. I'll start from 2. Okay. So in this, he's using 16. Okay. Let me try with 18. Okay. Because this was 3, I think 90 days back, we have tried with Ubuntu 16. Now let us try with Ubuntu 18. If it fails, let it fail. We'll try to find out that it is failing. Okay. Clear on this? So the only difference which I'm trying to do in the classroom is, okay, I'll add some more nodes also. I'll make it 4 eventually. But to start with, I'll start with 2 nodes. One master and one node. Let us do that installation correctly. And then we'll add nodes. Okay. Right. So we'll start with 2 nodes. One will be master and one will be node. And after that, we'll be adding some more nodes depending on what we have done. Okay. So what I'll do is, okay, I'll close all of this. I'll have 2 documents in place. One, I'll be using the Kubernetes official documentation. The second one which I'll be using is this instruction. Okay, right. So I need machines. So I'll be using cloud. Since majority of the people use Amazon, that's the reason why I'm using Amazon. It doesn't matter. I need 2 Ubuntu machines. And if you are using Google Cloud or Azure also, you should be able to create 2 virtual machines. So that's not a very difficult thing. For the people who don't know how to create virtual machines, I think you can go to the video content section and I've uploaded some videos. You can basically look into how to create virtual machines there. Right. Okay. And one more thing. So many people, right, you will install kubeadmin. If kubeadmin is working, I know Kubernetes. No. Right? DevOps is not about installation. The most easiest job in DevOps is installing software. Okay. Docker install చేసి Docker వచ్చేసిందని, Jenkins install చేసి Jenkins వచ్చేసిందని ఆ రోజులు పోయినాయి. No. Right? So just installing Kubernetes doesn't mean that you know Kubernetes. Right? Using Kubernetes effectively is a point where you can tell that description, not because just you are doing installation of it. Okay. Right. So let me go to EC2 instances. Here the best part is T2 micro. I don't think so you'll be able to use. Okay. Right. For nodes it is fine, but not for master. So let me terminate them. Okay. So let me start with it. So I want to install any of this. Okay, as I said, you can use Red Hat 11, Red Hat 7 also. But the point over is it has some dependency with the subscription which you have taken. Okay. Otherwise, you can try on all of this machine. So what is the minimum RAM he is trying to tell? 2 GB or more RAM. And then you need, but T2 micro is a machine where you have 1 GB of RAM. And don't try to install it on T2 micro and say my Kubernetes is not working. It might not work or it will not work. If it is working, you are the luckiest person on the planet. It is the right time to go to interviews. Okay. Shukramahardasi ప్రారంభమైందనుకొని ఇంటర్వ్యూకి వెళ్ళిపోండి. By default, if you are using T2 micro, it will not work out. So what are the other options available? Okay. So if you open an Azure account, you will be getting $200 of credit. Okay. There you will be able to create 4 virtual machines at least. So go and create, okay, 2 core machines there on Azure. Okay. Right. So for me, it doesn't matter because I am not paying the bill of this. It's okay. Right. So I'll go over here. I'll say launch instance. Okay. And as I said, I'll be taking a Ubuntu 18. And we require at least 2 virtual CPUs and 2 GB of RAM. I think this is the nearest possible combination which I have. So I'll be taking T2 medium. Yeah. Okay. Next. Number of instances which I want is 2 at this moment. 1 master and 1 node. Okay. 8 GB of RAM is enough. 8 GB of disk is enough. Tags I'll add it later. Okay. Security group, what I'll do is I'll try to take a security group where everything is open. Okay. Right now I'm not putting any restrictions on network. Okay. So review and launch. Launch. And I'll be taking a key value pair, which is a Linux bootcamp. And let me click on launch instances. So I'll go to services and EC2. Okay. So over here I have a lot of machines that are present over there, because for some time it will show you terminated machines also. So I'll be saying that I'm interested in the machines whose instance state is running. This first machine I'll be calling it as master. This is for my reference. And the second machine I'll call it as node 1. Okay. So this machine will be my master and this machine will be my node. Okay. So right. So then full network connectivity between all the machines in the cluster. Right now it will not have a problem because two machines are running in the same network and we have enabled all the communication by removing the firewall rules. So which is security group, everything is open, right? So unique host name, obviously we'll get a unique host name. So you need not worry about it. So if you want to still verify your IP connectivity, he's trying to tell that this is what you can do. Check network adapters. You might need to do this if you're running it on premise, but on the cloud, you don't need to do this because all of this will be satisfied. Okay. So you don't need to do any of this. But if you really want to open only specific ports, this is a list. So right now, if you have seen me, I've opened all the ports, which is not a good thing in your office. But in your office, if you want to open only specific ports, this is a table. Okay. On the control plane node is your master. On the master, open that ports, and on the node, open these ports. Am I clear on this? And as I said, the communication between master to node is all TCP. All TCP. If you see the whole protocol list which you are seeing over here is a TCP based communication. Okay. Clear? Yeah. Right. Fine. Now, in Docker, you can, or in Kubernetes, you can use any container technology. So right now in this list, if you are seeing, so let me expand this. In this list, if you are seeing, he's trying to tell that there are 3 container technologies. One is Docker. The second one is Containerd. The third one is CRI based, and you can use any runtime. And obviously, you'll be using Docker in this classroom. All right. So if you want to install, okay, just click on container runtime. Okay, and I want to install Docker. And for installing Docker, I'll be following this. So can't I install Docker using whatever script which I used to do that? You can do that one also. But this is very much guaranteed to work because the basic problem is Kubernetes, okay, is designed to work with Docker versions. Okay, also all latest. But sometimes what happens is the latest version might not be tested on whatever Kubernetes version which you are trying to install. So in these instructions, you will always have, okay, the latest version of the Docker, which Kubernetes has tested, which is guaranteed to work. Okay. But if you do it using get Docker script and all of that stuff, the problem with that is that will always go to the latest version and there might be some problems. It is not that there will be problems, there might be some problems. So I'll be following this for installing Docker. So on the 2 machines, I'll be running this script first. So which will install Docker on the machine. So that is what even this speaks about. Okay. So log in into all the 3 nodes, install Docker from the steps from here. If you see, it is pointing out towards the same stuff. Yeah. Okay. So you can basically follow the links from here also. Okay. And then log in into all the nodes and all of the stuff which I'm trying to do, everything is documented over here. So you really don't need any other stuff and I'll be following the same stuff. The only thing which I've changed in this is here it speaks about 4 machines. I'm speaking about 2 machines. Here it speaks about Ubuntu 16. I'm doing it on Ubuntu 18. That's the only difference. All right. Okay. So I'll go over here. Shall I log in into the master and install Docker there? Yes. Okay. Fine. So I'll go to this page. Okay, what is it trying to tell? App get updated and app get installed and all of that stuff. And for that to work, you have to run as root user, which is sudo -i. Yeah. So Blindly copy these commands one after the other. Okay. Okay, just because you are copying this, you don't know Kubernetes. Understand that. నేను చాలా మందితో మాట్లాడాను Kubernetes వచ్చా అంటే ఇన్స్టాల్ అయింది అన్నారు. I've spoken with a lot of people. I've asked them, did you learn Kubernetes completely? Yeah, I've installed Kubernetes. Okay, learning Kubernetes is not equal to installing Kubernetes. All right. ఇది నేను ఎన్నిసార్లు అంటున్నానంటే నాకు ఎన్ని చేదు అనుభవాలు ఉండుంటాయి ఆలోచించు. ఓకే, ఓకే, ఓకే. I'm not even using my intelligence or brain around it. Blindly copy paste. I'm quite sure it will work. Okay, but if you are doing it on a CentOS node, right? Select this. Okay, so if you want to do the same stuff on CentOS 7 and all of that stuff, then copy paste these steps. Right. So since I'm using Ubuntu or Debian flavor, I'm using these steps. Right. So my first task of installing Docker on master is done, but I have to install Docker on nodes also. So let me log out of this. Okay. Now I'll log in into the node. Okay. So if you come from Ansible background or if you know shell scripting, now what you can do is try to write a shell script which will do all of this. Right? On the machines you will execute that shell script, your Docker is already installed. Yeah. Okay. Sudo -i. Okay. 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 So the Docker working? Yes. Okay. Right. So on both my master and node, Docker is installed, and if you look into it, log in into all the nodes, become a root user and install Docker by following the steps from here, and I've done this step. Now let me go to the next step. He's asking me to install kubelet. Okay, and I'm quite sure we know what a kubelet is. Okay, kubeadmin and kubectl on all the nodes from the documentation over here. Okay, fine. So we can basically install our Kubernetes stuff, whatever is required by basically executing this stuff. Okay, and now here it says, okay, install the kubelet and kubeadmin on all the nodes from here. Okay, we will be installing kubeadmin on all the nodes, but we will be initializing on only one node. Okay, if you remember, this is much like your Docker Swarm. Docker Swarm is present on all the machines, but where we do init, that becomes a master. Where we follow, where we become a node, that becomes a node. The same story over here. So even if you are following this documentation, okay, sorry, saying this is the next step. Okay, so I've given the same thing, but the whole point is, rather than basically going through all of this, I'm asking you to install by following the documentation, because it is one line describer over here. Okay, so I'll click on this. Sorry, control click could have been better. Okay, all right. So over here, okay, Ubuntu stuff, and then if you're using a container Linux. So let me log in into my master. So my master should be this machine. Okay, I can easily find it out. So on the master, I have EC2-52. Okay, and my private IP address is 32.59. Are you seeing 32.159 over here? So I'm working on master itself, right? So okay. Now after that, do that line by line. Okay, but whenever you see this red line, this means that from here to here of all of this belongs to one. Okay, right. Match it. Right. Right. Okay. Right. So then he's trying to tell that if you are basically using a C group driver, remember that you might have an extra set of arguments. Okay, we'll come back to this at a later point of time. So at this moment, you cannot, there is no need for you to worry about it. But if you want to restart this kubelet, you can execute these commands. Okay, but I have to execute this on the other machine also now. Okay, so exit. I'm logging into my node, and I have to re-execute the same commands. It is not difficult. It requires patience. That's the whole point. Okay. Okay, and if you follow the other method, right, cube spray and all of that, it is not guaranteed that you will have same steps. The only step that is guaranteed is your Docker installation will be same. After that, whatever you install might differ from application methodology to application methodology, right? Yeah. Right. Okay. Fine. Now let us see what is trying to tell. I've installed Kubernetes. Now we have necessary softwares. Now what is that we need to do? We need to create a Kubernetes cluster. Then he's asking us to create a Kubernetes cluster by following the documentation from here. So if you are creating a Kubernetes cluster, right? So are you saying Kubernetes administrator? Oh, good. They have done it, man. Now Kubernetes can be used on basically production servers also. They have made it everything generally available, right? Last time that was not the case. Okay, right, fine. So, right. Are you saying cube admin and then init? Okay, so basically that is the command which you need to execute. The moment you say cube admin init, it will do all of this stuff and it will try to work with it. Okay, but remember, after we install Kubernetes, we'll be installing something called as pod network for that kube proxy. Okay, whenever we are basically doing this kube proxy, we have many variants. We'll worry about what these variants are at a later point of time. Okay, but if we are using flannel, okay, remember that you have to, while you are doing init, if you don't pass this, you cannot create a flannel network. Okay, so for all the other things, if you just do kube admin init, like Docker swarm init, that is enough. But if you want to create your pod network with this flannel is networking implementation, right? If you want to use flannel, you cannot do that without passing kube admin init hyphen pod network and give some CIDR range over there. Give some CIDR range over there. Okay, that's the only thing. So if you want to use ViewNet, no need to worry about it. So, but if you want to use a flannel, then you have to pass this stuff. Am I clear on this? Okay. Apart from this partner, the reason I am speaking about it is tomorrow if your company says that use flannel and then you say kube admin init and after that you basically apply this flannel and then your Kubernetes cluster will not be up because flannel will work only when you use the init command with hyphen this stuff into it. If you don't do this, your flannel will not work. Okay. So, but if you want to use any other network provider, then you will not have a problem. Then you will not have a problem. Clear on this? Yes. So for example, whenever you are installing Kube network, please come down to the pod networks and see what is the network which you are going to install. So today you might not have a knowledge of what this pod network is, fine, but you'll be learning about it very soon. Okay. But understand it as an implementation of your networking. Okay. And there are many providers that implement networking. For example, if you are installing Kubernetes on AWS using EKS, they have written their own network driver. Okay, this is network driver. In the case of Docker, we have something called as pod network over here. Okay, these are many third parties who have basically used the pod network. So we have many options over here, right? So if you want to install any of these networks, you have to basically execute very simple commands. But some commands require, for example, you have to use hyphen pod network CIDR. So in this class, what I'll be using is I'll be using ViewNet. ViewNet doesn't expect you to write hyphen pod network CIDR, but it is an older one. Flannel is a much better option than this, but still we'll go with ViewNet. అంటే ఆ రెండిట్ల మధ్య తేడా తెలుసుకొని మనకి మారిపోయేంత అద్భుతాలు మనం ఏం చేస్తలేదు కాబట్టి పర్లేదు, right? But once you get into the actual networking, when you are installing the Kubernetes, choosing the pod network is also an important option. But today we are not that literate to understand pod network, so I'm not discussing too much. So what I'll do is I'll basically install the kube admin initialize, and then I'll be using my network as ViewNet, my pod network as ViewNet. Okay, so right. Sorry, saying is basically trying to tell that log in into the master node as a root user. Okay, so now I am not in the master node, right? So what has happened, man? Enter కొట్టలేదు నేను. Okay. Okay, good. Okay, so I have to become a root user. So I become a root user. And then I'm following this documentation. Cube ADM init. Okay. So this cluster over here will tell you how to basically do the stuffs. The whole. Okay. So all of whatever I'm doing is basically from here. Are you seeing cube ADM init? Yes. So whatever I'm doing in this classroom is basically from this documentation over here, but I've tried to simplify that by doing this activity. Right. So cube ADM init. But remember, if you are using a different kind of a network, then you might write hyphen pod network CIDR and all of that. If you want to use a flannel. Right now I said that I'm not going to use a flannel, I'm going to use a ViewNet. Okay. So that's the only thing which. Pardon me? No, there is no default network. You have to implement some default network. For that default network, you have many options in Kubernetes. In Docker, generally what happens is when you install Docker, you will basically get that default network in place. In Kubernetes, you will not get it. So for the default networking, you have to tell what is the implementation which you would like to use. So this will take some time. So once this is done, your master setup is basically done. Okay, right. So are you saying from here till here, copy this commands, and if possible, install a software called as Notepad++, and then paste all of them. We are going to use them in the future. Okay, so are you saying now, if you want to install a pod network, you have to do this. Before you start using something, you have to do these operations. And if you want to join any worker nodes, you have to execute these commands. If you remember, it is very much in sync with what we have done in Docker Swarm. Docker Swarm init, it has given us some commands. We have pasted that commands, and when we were joining the nodes to the master, we have copied and pasted this stuff. Right? Okay. So now what I'm supposed to do is become a normal user. Okay. So 1 minute. I think this will be very bright. Okay, let me get this. It is not that bright, right? First రోజున అంత బ్రైట్ గా ఉందా? ఆల్రెడీ కాటాకి వచ్చేసినట్టుంది. సినిమా వేసినట్టు వేసేస్తున్నారు దీన్ని. ఓకే, బట్ స్టిల్ మన తప్పు లేకుండా I don't want it to be impacted. So, okay, this is looking better to the eyes, right? Yeah, we'll use dark themes. Okay, fine. So, basically, what is it trying to tell us? To start using this cluster, you need to become a regular user, not a root user. You cannot execute this as a root user. So, to become a normal user, what should I do? I'll just say exit. Okay, so now we are a normal user. Now, over here, blindly copy paste this command. So you can regenerate that, but for today we'll be using whatever it is. We will not be using much brains. We'll be just following this documentation, right? Yeah. Then we will understand what the token is, how it can be regenerated, and all of that stuff, right? Yeah. Okay. Okay, the reason why we are doing this is you want to run kubeadmin, okay, as a regular user, because your regular user has to execute this commands. Otherwise, only the root user can execute Kubernetes cluster, which is not a very good idea. For that reason, he's asking us to do this stuff. Okay, and then what is it trying to tell? You have done this now. You have to basically create a pod network. So to create the pod network, okay, in Chrome also we have a dark theme, right? Yes. How to enable that? Let me enable that one. It is difficult for me itself. So change the desktop background color. ఇది చేస్తే క్రోమ్ ఎలా చేంజ్ అవుతుందండి? Pardon me? It will be in the themes, is it? 1 minute. I know people on the web, you might basically not understand, but actually we have a very dark and black themes. This one, this is enough. Add to com. Okay, good. So if you okay, fine. మరి దానికి డెస్క్టాప్ బ్యాక్గ్రౌండ్ ఏంటి సంబంధం సాదత్వం కాకపోతే రైట్ ఫైన్ దెన్ సో remember our pod network over here there were many. I said that I'll be using VNet. So for VNet, are you seeing this command? Yeah, so blindly copy this command, okay, and then run it from here. Is it fine? Okay, now let us get into the documentation. Okay, so he also is using the View network over here in this documentation, and then first let us basically execute this command saying that cube ctl get nodes. It says that right now you have only one node. Yeah, we have not joined the node yet, so cube ctl get pods. It says you don't have any pods at this moment. Okay, so but they are seeing something called as a namespace. We don't know what a namespace is, so I am not getting into that. Fine. Okay, so what we will do is let us go ahead and join our node to this master. So for that I have to, pardon me,
Token is not fully copied.
fully copy all of that. Oh, ఇదే కదా వచ్చింది కదా ఇప్పుడు. యా, ఓకే. సో రైట్, basically I'll copy this, and if you see, you can join any number of worker nodes by running the following command on each worker by logging in as a root user. Okay, so if you are reading the documentation, then you will not have any problem, but if you mess with that, you will run it over here and it will not work. So try to become a root user and then execute this. So he's trying to tell that, okay, this node has joined the cluster. You can go to the master and then execute kubectl get nodes command. Okay, and remember, if you forget to install the pod network, right, your nodes will not be in ready state. You will see the nodes, but nodes will not be in a ready state. Okay, so kubectl get. Okay, so generally if you give -w to your commands, okay, it will show you till the state changes. So in Kubernetes have that -w. So whenever you are trying to execute some command and that command will take some time to reflect, we want to see all the changes, then kubectl get whatever it is -w. If you see -w, when we started this 32, it was not in a ready state. So when it has turned ready, it has shown us, rather than you executing this command multiple times, -w, which basically stands for watch this command for changes. Watch this command for changes. So now if we execute kubectl get nodes, we have two nodes. So does all the three are in what do you call ready state? Yes, good. Okay, fine. Can I use this setup in enterprise? The answer is yes now. Okay, when this document was written, it was No, because there were some components which were in beta state. Now, while reading the documentation, I have shown you that everything is in GA, general availability. If they are in GA, Kubernetes will support it. Okay, that's the whole point. Okay, right. So, fine. I'll not get beyond it. In Kubernetes, generally, you will create two kinds of units. One is a worker, the other one is a controller. Okay, worker is who does the work. Okay, and then we have controller. Controller, what it does is it will have that capability of making it self-healing. Okay, so for example, if you run the worker on Kubernetes, it will still, if that worker goes down, then it will not automatically self-heal. For example, we were running Docker container run command. If your container is dead, will something happen? No, right? Similarly, in Kubernetes, if you run the worker directly, it will not automatically self-heal. So for that, we have to create something called as a controller. Okay, so but before that, we have to understand that very important things in Kubernetes. Kubernetes has something called as objects, right? So what are Kubernetes objects? And Kubernetes has something called as namespaces, right? So we will be getting into all of that stuff. For today, with respect to Kubernetes, just install this. Now, if I add one more node, what is it all about? Go into that node, install Docker in there by following the documentations, and then log in as a root user and execute this command. Yes or no? Now you can add as many nodes as you want. Okay. But remember, this is a time-taking activity, but understand this is for the machines which are running in your office. Okay. These are not cloud VMs. These are the virtual machines which are present in your office, and then you want to install Kubernetes on your own. That's the case where you use kubeadmin. Clear on that? Yes. In reality, our production setup will be on cloud or whatever the provider is. Okay. Kubeadmin also can be made highly available. So you can, rather than having a single master, you can make it multi-master also. Okay. But in this class, we'll not be worrying about it. We'll be worrying about multi-master case at a later point in this, right? So in Kubernetes, we need to understand many things now. We need to understand objects. We need to understand various different things. So for today, your responsibility is just try to install Kubernetes. Okay, using kubeadmin. Okay, so kubeadmin will be a decent setup in your organization when they are starting Kubernetes, right? So you will take 2 or 3 VMs, and then your application, whatever is running in the Docker container, you will try to pour it on Kubernetes, and you can basically start. So every company, when they start with Kubernetes, they start with some kind of a local setup, and kubeadmin is what they are using mostly. Okay, because it is simple. So if you can use the was just simple. If that is your question, look at other installation methods. Okay, ఇది సింపుల్ గా ఉందా, ఎలా ఉందో సింపుల్ గా, ఇది సింపుల్ గా లేదు కదా అని మీరు అనొచ్చు. యా, it might not be simple for you, but if you compare this methodology with all the other installations of Kubernetes, this is a simple method available. Yeah, clear on this? Yeah, right. Okay, then fine. So let me see if we have any doubts. Okay, is the pod network configured or installed on master? Okay, if you have understood correctly, the pod network installation, I have applied it on master itself. Once I have applied it on master, then it was applying all to the nodes. kubectl apply command of weave network, I have executed it on master, not on node. Yeah. Okay. Your doubts, ఏమన్నా సార్ మళ్ళీ ఇంకోసారి టైప్ చేయండి, నేను మళ్ళీ వెనక్కి వెళ్ళలేను. Right? Okay. If you use T2 micro, is it charged? No, T2 micro is not charged. Other machines are charged. Okay. All right. Okay. The pod network is configured or installed only on master. ఒకసారి చూసేద్దాంలేండి మళ్ళీ. 100 Kubernetes. Okay, ఇవన్నీ అయిపోయినాయి కదా. Can you please tell me few differences between Docker, Kubernetes, and disadvantages and advantages? We don't know enough Kubernetes yet to speak about differences right now. We still have to learn too many things before I point out difference. Today, the only thing which we know is installation method of Kubernetes. We are using something called as kubeadmin. So at this point, your differences are not huge. Okay, but as we learn some more topics, then we will come to a state where we will worry about differences. Yeah. Okay. So what is the communication protocol? I said it is TCP. Yeah. If the node dies, I think this was done, man. When a node dies, what is the flow of creating new node? ఎన్నింటికి 8-17కి అసలు బేసిక్ గా బ్రెయిన్ వాడతాం మానేసినట్టున్నాను నేను. 9 తర్వాత ఆలోచిద్దాం మనం. Any best ways of installing Kubernetes on production environments? It depends on what is your environment. So, for example, VMware is also distributing Kubernetes environment. There are many companies who are distributing Kubernetes environment. So, in Kubernetes, there are only two choices: whether you want to do the installation or whether you want to take the installation from some other third party. Okay, there are many companies who give you the turnkey kind of solution. Turnkey is you basically download it, you start working with them, right? Yes. Okay. YAML recording video, you will get it today. Okay, so I have not started anything about YAML, right? So you will get it today, right? So what is kubeadmin here? Kubeadmin is an installation methodology, right, to set up a Kubernetes cluster. Kubernetes can be installed in various ways, and for every way there will be a name. So right now, for installing Kubernetes, we are using a methodology which is called as kubeadm. Okay, right. So what is CI/CD pipelines now? Can we do the Kubernetes installation on Azure? In Azure, can you create a Ubuntu 18 machine? Yes. If yes is your answer, you can follow the same installation over there. Because here what I am trying to do is, what I need is, I need 2 Ubuntu machines, which are connected to a network, which has 2 GB of RAM and 2 CPUs. It doesn't matter where they are. And ensure they have internet connectivity, because we have to download them. Okay, right. T2 micro will not work. No, sir. Okay. Can we use T2 medium? Any idea what will be the cost? Okay. So I don't remember the accurate cost, but we can try that. T2 dot medium. Direct T2 series scale. No? Really? T2 medium. Yeah. ఉందా ఇందులో? ఇక్కడ ఓకే ఓకే, నేను ఇందులో ఉందేమో అనుకున్నా. ఓకే, ఇదంతా ఎందుకంటే డైరెక్ట్ గా T2 మీడియం వచ్చిందా? ఓకే, 0. నిజమా? ఐ విల్ నాట్ ట్రస్ట్. Okay. So we are taking a Linux machine, which is Ubuntu. Okay, or CentOS, if you come, it will come to this stuff. And right now, I'm using T2 medium. T2 medium is 0.064 USD to. So this machine will cost you approximately 3 rupees per hour. Okay. So, okay. You can use swap, but you will still see sluggishness. Okay. Swap memory use cheste manaki entante your requirement might be met, but your system will be dead slow. Yeah. Okay. What is bootstrapping after Linux command? I didn't got it. What is bootstrapping? Where did I use a word called as bootstrapping today? Sir, మీకు నేను చెప్పిన భాష ఎగ్జాక్ట్ గా వస్తుందా, ఏమైనా తేడాగా వస్తుందా? Today we have initialized the cluster, right? I never used a word called as bootstrapping today, right? We have taken a Linux machine, we have installed it, we have installed the stuff, and then we have installed the pod network, and then we have initialized the Kubernetes cluster. Okay. So there is initialize and tear down. Bootstrap on the padam ekkundi? Right. Okay. Fine. Kubeadmin doesn't need to be installed on the root user. See, all the methods of kubeadmin has to be on as a root user itself. There is only one command. While you are executing these commands, you have to become a non-root user. If you become a non-root user, what will happen is, after that, any command which you want to execute on a master node, you need not be a root user. You can log in as a normal user and then execute these commands. All right. You are logging in into using EC2 machines using git bash and EC2 PEM keys, right? How many EC2 machines should we install Kubernetes on? Only on the master. See, so we have not installed, we have installed, if you have seen or followed our installation methodologies correctly, we have taken 2 machines. One machine is a master, the other one machine is. So softwares till some point, till you install kubeadm is exactly same on master and nodes. On the master, the only thing that is special is I'll be initializing the cluster, kubeadm init, and then I'll be applying the pod network on the master. Okay. But prerequisite software in the case of Kubernetes admin is same. There is no difference. Okay. Right. Init and planner, boy. Kubeadmin okay. Kubeadmin init, what it will do? It will set up the Kubernetes cluster for you. So if you remember, I'm not sure how many of you looked into, but in Docker Swarm also, whenever we wanted to initialize that Swarm mode, we have set that Docker Swarm init. Okay. So what has happened then? Then we were suddenly capable of making this machine available for others to be connected. So if you remember over here, I have done kubeadmin init and I got this. Okay. Then I have executed this stuff. I have installed the pod network. Then I have logged in into the other machine. I have executed this command and those two were part of one cluster now. Now I have a cluster of two machines. I have a cluster of two machines, one master and one node. Yeah. Okay. Docker Swarm, we have 5 networks, the same in Kubernetes also. Docker Swarm, where we have 5 networks? Okay. Sir, మీరు పోనీ ఈసారి సెలవులకి మీరే వస్తాను సార్. I'll come to your hometown this time. Just tell me where you are staying. In Docker, we didn't have 5 networks. We had 5 network drivers. Host, bridge, right? That was there. Here, this is not equivalent to your bridge. This is a whole pod networking. This is a multi-host networking. So, if you are speaking about a multi-host, in the Docker, we had only one driver. That was overlay. Yeah? If you are really compare with the stuff, not with numbers. Right? Okay. Can we do Kubernetes installation on Azure? Whatever installation which I have done in the classroom today has nothing to do with Azure or AWS or Google Cloud. I need 2 Ubuntu machines which are in the same network, which have an internet connection, and each machine should have 2 GB of RAM and 2 CPUs. Right. T2 micro will work. No, it will not work. What is bootstrapping? I don't know what is bootstrapping. Right. Docker Swarm, I am not sorry. Are you going to show EKS cluster in AWS? Okay, I will show EKS cluster, but to go to that point, we have to know a hell lot of Kubernetes, and today we don't know anything about Kubernetes apart from Kubernetes installation. Okay, Kubernetes lo manaki emi raadu inka, right? ఇవాళే పలక్ కొనుక్కున్నాం, రేపటి నుండి అక్షరాభ్యాసం, రేపు బాసర వెళ్ళాలి, రైట్? దగ్గరికి ఆ పరిస్థితిలో ఉన్నాం మనం. We don't know anything about Kubernetes yet. We just know how to install Kubernetes, that too on dev and test environment. Yeah, right. What will happen if we have a DB schema change? How will we roll back and roll out the server? Okay, so if you roll back and roll out, okay, so you should have a backup of your volume, right? Database schema change or whatever it is, that is stored in some kind of a volume. You ensure that you have that backup taken and reload that volume. Then it will be reverted back. Yes. And one more thing, whenever you are basically doing DB changes, okay, schema changes, on the case of Docker, whenever you do that change, there are some best practices. That means you need to have a disk copy. Yeah. But you will have some efforts also, because whenever you are trying to basically upload the data, sometimes that schema changes might not be very simple. It might need to be reworked on. Then you have to do all of your ETL practices. Docker will not automatically do. Okay. So for example, your existing records name, columns name was some X. Now you have changed it to Y. Okay, that will impact all the records on your system. Okay. Some of the records, if they are in use, right, it might be a difficult option. So in that case, what you need to do is, before you do this migration, first perform an ETL operation. Just migrate that to a different Docker container and then try to run it. Okay. You will not do that deployment on the fly in that way. Right? Okay. Can I use Chocolatey for installation? Adi. Chocolatey will work only on Windows, and right now we are using Ubuntu machine. So the answer is no. Right? What is the most preferred methodology for Kubernetes installation? For dev and test environments. That means as a setup in your office, kubeadmin is still most widely used. Okay. On the production, you have options, right? Yes. As a DevOps engineer, admin, this Kubernetes installation is responsibility of ours or admins. If there are DevOps engineers, who are admins then? So in my company, if I have DevOps engineers who are responsible for configuring all of my systems, I just, okay, who will give me Linux operating system, Windows operating system, and all of that stuff. Rest of the stuff will be managed by me. So there are no admins. Don't worst case scenario. So you will you will not have an admin. Even if you have an admin, he will give you a Linux machine with Ubuntu installed. Okay. At a max, he might configure a network for you, not the other stuff. Installing this will become your responsibility. In installation, wherever you think, right? But for this installation, the only thing is, okay, you need to automate this installation. That's where what you might do is, remember we have learned Terraform? Yes or no? For the people who have learned Terraform, right? For the people who have learned Terraform, in Terraform, can I create these two Ubuntu machines? So from Terraform provisioning, can I log in into one machine and make it as a master? Yes. So that is what you try to do as a DevOps engineer. Rather than doing this activity every time and again, you will write automation around. Okay. But you have to do it manually at least once. That is what you aim for. Okay. And there are a lot of Terraform modules are already written, which can set it up for you. But while you are practicing or learning, don't do that. Try to do it on your own. Yeah. Okay. Fine. Sir, are you going to show us the EKS cluster? I will, sir. I will. I said that we are on the very, very initial phases. Okay. So think of that you are in LKG still. You have to write an MSET exam. We have a lot of things to learn. Okay. Cluster matter fails. Still high availability available. How? Engine fail అయితే కార్ వెళ్తుందా? 1% chance ఉందా? Your engine is failed. You want to try to run the car and you don't want to take the help of other car. Can you use that car? Is it possible? Okay. Same thing. Here the engine of your Kubernetes is your master. Okay. So in the aeroplanes we have two engines. If one engine fails, the other engine comes into play. That is high availability. Now we have only single engine. Engine is failed. Ante. Right. So yeah. మీరు ఎవరితో వెళ్ళారు అన్న దాని ప్రకారం అది డ్యూయట్ సాంగ్ లేదంటే భయంకరమైన పాట అన్నది డిపెండ్ అవుతుంది కానీ బట్ ఇట్ ఈస్ అ ఫెయిల్యూర్ రైట్ ఓకే అండర్స్టాండింగ్ ఇన్స్టాలింగ్ కుబర్నెటస్ విత్ డిప్లాయ్మెంట్స్ టూల్ bootstrap clusters with kubeadm. So yeah, it is initializing. It is not really bootstrap. It is not really bootstrap. Even though, see, bootstrapping is something like this. Whenever you use a word bootstrap, that means that while you are starting something, you are doing some activity, right? So, for example, in Chef we use something called as bootstrap and node, okay, to install a Chef agent into that. Okay, here you are initializing a cluster still. Okay, there is not much of bootstrapping which we use over, right? Yes. Yeah. Wow. If you have 100 nodes, it is difficult to perform or add them manually. Anyway, the node is, that is why you are learning this course. You are supposed to give that idea, right? So since it is very difficult to install a kubeadmin cluster time and again, what tool can I use to automate this? Can I use Ansible? Can I use Chef? And by the way, you can use any of those tools. Can't I do this in Ansible? Yes. You have a Ubuntu node, log in into the Ubuntu node as an Ansible, try to write an Ansible playbook and automate your Kubernetes admin installation or master installation, right? There are many ways of doing it. What is suitable for your organization is you need to know different set of tools. Right? Yeah. Okay. Then practice automation kalante meeku DevOps raadu. Right? So for practicing itself, I need an automation automation, that will not be possible. You are responsible for automating these activities. You will be able to automate if you are not good with manual steps. Understand that thing. No automation is possible if you don't know how does that work manually. So that the whole idea is first try to learn the manual. Okay. Then using Kubernetes, you cannot automate the Kubernetes deployment. But using other tools, you can do it. So once we learn something called as Ansible or Chef or Terraform, try to see how can I automate this. Yes. How to Kubernetes UI? I will not be interested in that. Okay. I am a person who hates UI. Put it in that way. If you have observed me, I am very bad at using mouse also. Right? I'm not sure how many of you have observed it. But at the last, I'll show you UI. Okay. So we will be working on CLI completely. See, understand one thing. Our job is creating a pipeline and deploying your applications to the Kubernetes. During this time frame, if you use UI, you will not be able to automate. So we use UI only to one thing. Okay, we are running all of this Kubernetes. We want to just see what is running over there. Okay, and that is not a primary responsibility of ours. Our primary responsibility of ours is to ensure your pipeline is created. Whatever code which your developer is committing, we are able to build the code. We are able to build a Docker image. We are able to push it to something called as a registry. From the registry, we are able to take and then we are able to deploy it to the Kubernetes cluster. That is our major responsibility. Yeah. After that, okay, how much is CPU behaving and all that stuff, depending on whatever environment which you have, you can use either existing tools or you can basically use the UI. But in my class, UI will be a least priority. Okay. UI Jupyter నాకు సుఖమండి. Right? So there are some UIs where you can right click on that and say Kubernetes cluster and all of that stuff. I don't want to do that because that is not real. That is good. Okay. To just show. Not reality, that is not something which you use, because anything which you use from UI cannot be automated. That's the bottom line. That's where we don't basically focus towards UI. Right. Fine then. So how to get the Kubernetes UI? We'll worry about it, but not today. You have to follow some steps, and those steps to get the UI are also command line steps. Yeah. You have to install some extra kubectl apply commands and all of that stuff, and then you'll be able to. But today we don't even know what a apply command does, what a get command does, what an object is. So let us become literate in that. Okay. So in the next class, what we will do is, that is tomorrow, we will start our discussion with Docker file first. Okay. We'll discuss about environments, arguments, and other areas. Okay. And then what we will do is we'll start discussing about Kubernetes terms. What is an object? Okay. So what is a worker? What is controller? Okay. So, and then we will be creating our first pod in the class tomorrow. Okay. And what does it take to create a pod? And what does it take to write a pod specification? So that will be our focus tomorrow. Okay. Pardon me? Master as an, yes, you can. Okay. You see, it will be, I'll put it in this way. On the master, you can run pods. If that is something which you are calling as nodes, yes. If you want to make a master as a node, remove the cluster which you have done. So kubeadmin init is to create a cluster. Kubeadmin tear down is to remove the cluster. Just if you tear down, that machine will become a node. Yeah. Okay. Today evening we will have a Linux class. Tomorrow morning we will have a Kubernetes class. Message says different, is it? మనకు తెలుసు కదా, రైట్? ఓకే. క్లాసులు రాకుండా కుబర్నెటస్ అనుకుని వచ్చిన వాళ్ళు రన్నివ్వండి. నాకు అలాంటి వాళ్ళు అంటే బాగా ఇష్టం. But for the people who have attended my classes, today morning and tomorrow morning we will be having Kubernetes, and today in the evening we have a Linux class. Someone who is not attending the classes and who only come to DevOps classes, right? Let us see. Okay. So నాకు తెలిసి DevOps class ఇప్పుడు అందరూ వచ్చి ఉంటారు. ఓకే. రానోళ్ళు ఎవరన్నా సాయంత్రం వస్తే వాళ్ళతో నేను పర్సనల్ గా మాట్లాడుకుంటాను. Right? Because in the classroom I have said that Saturday morning, because 6 hours of Kubernetes on the same day, you will fall into the same trap. You need one more day for practice. So that's where we are taking it on the first half of the hours, right? Even if your message says differently, tomorrow morning we have a Kubernetes class. Today evening we have 1.5 hour of network discussion and 1.5 hour of storage discussion, right? Yes. Okay then. Okay, one important question. Yes, what is that important question? Please. How are you able to manage your daily work watching these many movies? Actually, that could be the reason why I am able to manage. Since I manage those many movies, right? I somehow I am able to manage. Right. Let me tell you very honest. I don't like anything apart from watching movies and basically studying. That's the only two options which I have. So I will either sleep, I'll either learn something new, or I'll watch movies. Okay. మీరు చేసే చాలా సింపుల్ పనులు కూడా నేను చేయను. Okay. I'm quite sure that you might have seen me calling Nani to bring tea. Okay. It is not bossism, and I'm lazy. Okay. But I'm active only on these three things. All the other things I don't know. See, if you, ఇది చాలా అసహ్యంగా ఉంటుంది చెప్తానికి, కాకపోతే సమ్ ఆఫ్ ద పీపుల్ మైట్ బేసికలీ డూ ఇట్. If I go to my school, my children's school to pick up, they will ask me, who are you? Because I have never been there. So they'll call my father or my wife and say that someone has came to pick up your children. Is it okay to send? So there are many areas where I am lagging than what you do very well. Okay. So yeah, I have given priority to these three at the moment. So let us see what happens down the line. Right. Okay. Fine. What's Top Gun? Yeah. I will. What is a pod network and a weave network? See, for the pods to communicate, there should be some networking that is defined. Okay. And that networking is implemented by many different products. Okay. So there are many products which implement the pod network. Okay. Which make your Cube DNS work. So Cube proxy work. So ViewNet is one of them. So ViewNet is not different from pod network. ViewNet is a pod network. Flannel is a pod network. And each pod network will have some networking design specification differences. But today we don't know about them. But still I had to speak saying that there is something called as a pod network. That's the whole point. Yes. Can we? Not really. So for that you have to create something new. Once to one cluster you can have only one network. Yes. Are you from Machilipatnam? No, sir. No, I'm not from Machilipatnam. Yeah. Okay, మీరు అలా ఎందుకు అనిపించింది? బందర్ కాదు మాది. Right. Yeah. Okay. What is clear this question? I think I have said about that, sir. మీ గురించే సార్ నేను మాడింది. నా బాధ బెంగ అంతా మీరే. Right. Okay. Can I run my Kubernetes load balancer on a Kubernetes node? To be very specific, we will not be running a load balancer on a Kubernetes node. In Kubernetes, there is a wonderful concept called as service. Okay. So that service can speak with your load balancer. So we'll learn that. As I said, we are illiterate in Kubernetes at this moment. The only thing which we know about Kubernetes is installing kubeadmin. That's it. All right. Okay. It is not Kurnool, man. Unfortunately, it is Vijayawada. Right? Where I belong to, but I somehow don't like that place. I'm not connected to that place. I like Godavari very much. Right? విజయవాడ వాళ్ళకి నచ్చకపోయినా విజయవాడ పెద్ద గొప్పరేం కాదు, మీరు గర్వపడకూడదు. మీ ఊరు విజయవాడ అంటే చేతులు గట్ట ఎత్తకూడదు. మంచి ఒపీనియన్ ఏం లేదు విజయవాడ మీద. రైట్? సో whenever you say that, so is there anyone from Vijayawada? Please don't raise hands. Alright, there is not a good opinion in Vijayawada apart from Vijayawada. Vijayawada వాళ్ళే విజయవాడ గురించి గొప్పగా చెప్పుకుంటారు. పక్కూరు వాళ్ళు ఏమనుకో తిట్టుకుంటూ ఉంటారు మనల్ని. విజయవాడ, గుంటూరు, ఇలా గుంటూరు కొంచెం బెటర్, అట్లీస్ట్ కారం ఇలాంటి స్పెషాలిటీస్ ఏమో ఉన్నాయి. మనకున్న ఒకే ఒక్క స్పెషాలిటీ ఏంటంటే ఎదుటోడిని మోసం చేస్తాం, లేదంటే ఆడికి ముందు గర్వంగా బిహేవ్ చేస్తాం. ఈ రెండు పెద్ద గొప్ప క్వాలిటీస్ ఏం కాదు. బాగా ఉన్న వాళ్ళు అందరూ చచ్చిపోయారు. ఇప్పుడు ప్రస్తుతం విజయవాడలో గొప్ప వాళ్ళు నాకు తెలిసి లేరు. మీకు ఎవరైనా తెలిస్తే నాకు ఆత్రంగానే ఉందో నేర్చుకుంటాను. రైట్? సో ఎవరన్నా మీది ఏ ఊరు అంటే మాత్రం విజయవాడ వాళ్ళందరూ చేతులు ఎత్తారంటే దయచేసి ఎత్తకండి, అది మిమ్మల్ని తిడతానికే. రైట్? సో యా ఓకే. Nellore is good place, man. Nellore is a fun place. People, I have a lot of people, friends from Nellore. If you speak with them, they sound like they are scolding at you, but actually they are very affectionate. Right? Their slang is in such a way that it sounds like they are scolding you, but they are very affectionate. Right? Yeah. But actually, it was discussing about my hometown where we speak different slangs of the Telugu. Yes. Yeah. I will try to speak in English as much as possible, man. But somehow, sometimes, since from the places where I come from, we have to turn to native. But as I said, I don't have problem turning into or speaking Hindi also. Okay, I can manage little bit of Kannada also. Grammatically not right, but I can communicate at least. Okay, right. So, మన ఇంగ్లీష్ ఫస్ట్ టైం ఇంటర్వ్యూకి వెళ్ళినప్పుడు మాట్లాడతాం కదా. సో విల్ గో టు ద ఇంటర్వ్యూ ఫర్ ద ఫస్ట్ టైమ్ ఇన్ అవర్ లైఫ్ అండ్ అవర్ ఇంగ్లీష్ విల్ బి వెరీ కన్స్ట్రక్టివ్ ఇంగ్లీష్, రైట్? ఆర్ అండర్ కన్స్ట్రక్షన్ ఇంగ్లీష్, నాట్ కన్స్ట్రక్టివ్ ఇంగ్లీష్, right? So in the same way I have under construction Kannada, right? Yeah, I'm doing that. To be very specific, I am doing that. I watched 96 with subtitles. I was without subtitles also I was able to manage around 50% of 96. Okay, so one last thing to basically speak about is for the people who are interested in learning Python. Okay, next week 17th onwards from 5 to 7, I think approximately 7, I'm starting Python. Okay, and in that there is a free Python. Okay, so which has Python fundamentals and object-oriented Python. For the people who want to continue whatever you are basically, well, if you want to stick to the DevOps, if you want to stick to whatever it is, those two are more than enough. Since anyway it is for free. Okay, if you have time to cater, if you have still some spare time, try to join that. If you don't have a spare time, it's okay. This will happen for some more time also, right? So once in a month, every month I'll be starting a Python, approximately 1 month. It might take a little bit more than that. So I think you will get a mail from Quality Thought. You can look into the content. It is not like what we discuss in our DevOps. In our DevOps, we are restricted to scripting. There we'll speak about the whole Python. For the people who are interested in that, if you have time, you can attend that. Okay. But that is a whole Python course. I am not sure. If you want to become a developer, that will suit good. But if at least you are a DevOps engineer, try to make use of that. Okay. If anyone wants to start, if they're freshers and all that stuff, then ask them to at least, even if they are learning somewhere else, ask them to come to Python fundamentals class, because unfortunately, okay, our class will not be the same way like how people teach programming. I'm quite sure some of you might know that. Okay, we'll start from a different place. Okay, right. Only AWS plus DevOps. After Python, I'm speaking about Python and Django also, right? So after Python, we have two things. So if you want to speak me about a Python course, I think it sounds like an advertisement, man. I don't like that. But let me try to tell you. So we are speaking free Python fundamentals. Prapanchanta dani core Python అని పిలుస్తుంది. I am calling it as Python fundamentals. And then there is an object-oriented Python. Okay. This is called as advanced Python. Okay, ఇలా రకరకాల పేర్లు చెప్పి అమ్మేసుకుంటున్నారు, right? But for me, if the core is, you should know object-oriented Python also, and then you should know the Python fundamentals also, right? So these two are free. And after that, what we learn is we learn something called as unit testing with Python. As a developer in Jenkins also, whenever someone writes the codes, we have to execute that unit test, right? MEN test command. Yeah. Equivalent to that, in Python also you are supposed to write unit tests. For that, you will be learning PyTest. And then for any developer who is trying to become a developer, if you are using an object-oriented language, you should know something called as design patterns. So you'll be learning the design patterns. Then we'll get into the web programming, where we'll discuss about Django and all of that stuff. Okay. And then in Django, we'll discuss the whole website or web application kind of a design. Then we'll get into microservices. When we speak about microservices, we speak about Flask. We speak about database programming. In database programming, we speak about SQL Alchemy and all the other Node.js connectivity tools. Right. So this is the whole course. Okay. This is quite. Yeah, I wanted to add that, but there was one threat. So I wanted to add serverless very badly. So I have not written it, but serverless will be discussed in that class. Okay, as a part of microservice, we'll be discussing that serverless technology also. Then serverless and rate ad malli cloud service laga anipichindi nake, andike teeskanna, right? But I would that will be added to the course on what do you call. Anyway, it will be added because we'll be speaking about Azure functions and AWS Lambda and Google functions also there. So we'll be speaking about all the three. Yeah. Yes, online available. Yes. Yeah. Andy? Yes. Online is available. Okay. Fine. Python class, if you do online, okay, Yeah, syllabus, I think it will be shared. Yeah, it will be shared. Will it effective? Uh, if you do Python, will it be effective? It depends on what is the level of experience which you have. But I'm trying to tell this again. Python can add, what do you say? If you are very good at DevOps, it can help you in automating the activities. If you are not so good in DevOps, first become effective with DevOps, then you can focus on Python. Am I clear on this? So that is my statement. నేను ఎలాగో ఫ్రీగా చెప్తున్నాను కదా అని వచ్చి ఫ్రీ అంటే వచ్చి కూర్చోమని కదా మనకి ఇలాగే అలవాటు. ఫ్రీ అంటే ఏమో ఇందులో వెళ్ళి కూర్చుందాం అని, రైట్? డోంట్ డూ దాట్. బయట వాళ్ళకి ఓకే అది ఎలాగో దేర్ ఆల్సో సిన్స్ ఐ విల్ బి స్పీకింగ్ ఐఎమ్ ట్రైంగ్ టు టెల్ దిస్. ఇఫ్ యూ థింక్ దట్ యు ఆర్ గుడ్ అట్ DevOps, right? So then adding a Python to your profile will definitely help, right? So if you are still not so good at DevOps, you are unable to finish the practice of daily DevOps activities itself, then don't add one more headache to your life. Okay, finish this and then add. Okay, as I said, this will continue for some time. Next month also you can join. In the next 1 month, try to finish your DevOps activities. Yeah. So just because if you are able to manage time, if you think that you have 1.5 hour of time extra, then you can attend the classes. Don't just attend because okay everyone is attending. No. Yeah. Okay. 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 మరి అలా పొగడేకండి, నేను పాడైపోతాను. Right. You spoke as to one of us preparing migration and sent to us. What? I didn't got it. Migration you preparing and sent to us. Okay. Are you speaking about cloud migration? If that is the case, I've added a couple of YouTube videos. Time hotna. Aithe vellan. So for the people who have to go to offices, you can make a move. Yeah, I know some of you have to, right? Because people are asking questions, and I have to start one more online session on 11 o'clock. We have that weekly 11 o'clock meeting, right? Yes. AWS migration. Sir, there is a video that is added to YouTube without audio. Without audio. Because in the class for 1 week, you had too much of my audio, right? Now go through the documentation, look at that video, it will definitely help you. Yeah. Yes. Daily AWS DevOps activities. We'll speak about it, sir. Today I am running out of fuel now. Okay? అక్కడ ఒక 2 ఇడ్లీలు 2 బజ్జీలు నా గురించి వెయిట్ చేస్తా ఉంటాయి బయట, రైట్? టుమారో 1-to-1 connect. What need? Okay, there are many people who are basically want to speak with me. Okay, so that's the reason why I'm having that 1 hour session. Last week I think 4 people attended that, so this week we'll count it. Okay then, so fine, we'll meet again tomorrow in the class to basically continue the Kubernetes discussion. Session name. So yeah, I think I'm not sure, man. Do you people, how many of you didn't receive an email from me regarding what the links which you can follow? You can do one thing. There is one more way. So if you go to directdevops.blog, yesterday itself we have added this stuff. So if you want to connect with me on Facebook, this is the stuff. If you want to connect with me on LinkedIn, if you want to see the YouTube, just click on this. You'll be taken to the page. So yesterday itself we have added this. So this is the page where you have it. Yes. Not there. Not correct. అవునా? Yeah, you're right. Yes, I'll change it. I'll get it done. Okay. I'm not doing this activity. I have basically given it away. I've delegated it. So you might see some mistakes in the next 1 week to 2 weeks. So if there is any mistake, please keep me informed. I'll try to fix it. ఎందుకంటే I want to give that away to someone else. As I said, I'm lazy at doing many things. This is one of the example. I want to give it away to someone to do this.